Hi, I'm Betsy Rosenberg, and I am pleased to be speaking with Dr. Peter Roopnarine. He is the Curator of Geology here at the California Academy of Sciences in San Francisco. Thanks for joining us. We are here in this beautiful California Academy of Sciences, just incredible space. You come to work here every day. What is your daily focus?
Here in my technical my job, I have different facets to it. One is dealing with the public, and we're all about educating the public on the natural world, the beauty of the natural world, how it works, the problems facing the natural world today. And another large part of my day is research. And as a geologist, a paleontologist, a paleoecologist, what I do is I use the resources we have here, which are very large collections from the natural world, whether from the modern systems or from fossil ancient systems, to try to understand how what we talked about in the film, these large ecosystems, these collections of species, how they work, or when they don't work, why they failed to work.
So you study extinctions for a living?
Yes. I look at the fossil record, and with macroscopic organisms, that fossil record is about 540 million years old. And one of the things we learn about extinction is that it happens all the time. Species go extinct all the time, and you hear comments like 99% of all species that have ever existed have gone extinct. What I'd like people to understand, however, is that extinction is not a natural outcome or fate for a species. When a species evolves, there isn't something written in a book somewhere that says you will eventually become extinct. Extinction happens because evolutionary adaptation fails, and you're constantly trying to keep up with a changing environment, and sometimes that environment will change in such a way or to such an extent that exceeds your genetic capacity, your ecological capacity to adapt or to acclimatize, and when that happens, a species becomes extinct. So it's not a natural outcome. It actually tells us something about what went wrong in the history of this species. The other thing we know about extinction, and I think a lot of people are familiar with, is that we've had mass extinctions in the past. And that is, a mass extinction is when we have that sort of normal rate, if you will, of extinction, normal, that is suddenly accelerated tremendously and is compressed within a well-defined interval of time. We can learn a lot from those past extinctions because we look at what were the drivers, what caused them. What's happening today is, in a sense, very different from those past mass extinctions because it's happening very quickly. Perhaps the only other precedent we have was 66 million years ago when an asteroid collided with the planet, and then those extinctions were extended over years following the impact, but many of them would have happened within seconds, within days, within weeks of that impact, where you essentially had something, several times, many times, as energetic as all of the nuclear bombs in the world detonating within a second, a microsecond on the planet. We're that asteroid today because we're perpetrating environmental change. We're driving extinction at a rate that is, to the best of our knowledge, has only one precedent in the last 500 million years. But the good news is life goes on. The planet always recovers. We never really get back what we lost. There's a restructuring, and we got a new world with new dominant species, or new common species, and so on. So there isn't a recovery of the ecosystem. There's a restructuring of the ecosystem. The bad news is that these systems do seem to collapse. Our models tell us that they can be fairly robust to that, hammering away at them up to a point. And then they begin to unravel, and when they unravel, it happens very quickly, not necessarily in a time sense, but in that you keep tipping that ship, tipping that ship, tipping that ship, and then you get to a certain angle where it flips.
Yep.
That sort of tipping point sort of thing. That might unfold over a time period of years, decades, even a century, but once you get it rolling, the change begins to happen.
How can people really get that broad view? So even though they think this doesn't really concern them, or it's just one particular species, so what? Yeah. Why is that really not the proper focus?
The economy, human economies. There are some interesting similarities between the economy of nature. It's like Darwin's tangled bank. It's a web of life. It's the economy of nature. It's all of these organisms engaged in their own everyday individual activities from which emerges this functioning system. And that's not an accident. That's evolution, that's selection over time. We have systems that work, the organisms in there work together, not intentionally, right? Because you can have, we see in the aftermath of mass extinctions in the past, for example, the ecosystems that spring back in the immediate aftermath are usually what I would say are bad ideas. They don't persist, and there's a lot of shuffling and reshuffling of species before you get to something stable again. If people think of the human economy, it's very similar. You have individuals and individual agencies and agents going about their everyday lives with a single goal, and that is to acquire resources or provide a service in exchange for resources to ensure your continuity into the next day. And from that emerges a system that, while we might knock the modern system, one of the things about the modern capitalist economy is it generates a lot of wealth. And there are problems with wealth distribution and so on, but there's more wealth than there ever has been in the history of human civilizations. More people are better off than they used to be in the past, even though we have a large segment that's sliding backwards. There's some positive things, but we also know how fragile it is because of that interconnection. The more interconnected it is, the busier it is, the more reliant everybody is on it. And you tinker with one part of it, and it will have consequences, but it's sometimes difficult to gauge how severe those consequences will be and where those consequences will be felt. And that's the same thing with an ecosystem. It's complicated, it's complex, it's of low predictability, but we know that there are consequences to what we do, but I can't tell you exactly how quickly they will be felt, how broadly they will be felt. The bottom line is just don't mess with it.
So we've just seen this incredible film.
Yeah.
I can't imagine anyone viewing that and not feeling frightened, motivated to do something,
Yeah.
a range of emotions, grief-stricken, and these are not exaggerations. In the time since the film was produced, what has been your sense of optimism or pessimism about, are people waking up in general? And I know it's not enough, and I know it's happening too slowly, but have you grown more hopeful or not since this came out and we need to get it out there in a much bigger way?
I'm perhaps more hopeful in one respect. I think the message is getting out. I think scientists are being listened to. Other persons who are working on this issue are being listened to. The conversation is broader, so more people are aware of it. I'm not hopeful in the sense that I don't think we've taken any truly meaningful action. The problems have been piling on. Climate change, as you said, is a widely recognized problem. Now it's a severe problem, and yet there's very little action being taken to avert the bad consequences.
What is the timeline? Is it true that we have like 35 years before we start seeing major impact? And isn't 35 years a blink of an eye as far as time goes, geological time?
I think we have to think, so 35 years is nothing. It's a microsecond, millisecond in terms of geological time, in terms of how ecosystems function on a long scale, on evolutionary time. I think the problem in one sense is quite simple. And if you're driving too fast and you're heading into a collision, you know that you have brakes, and applying the brakes will stop the car, but you also know that you have to apply them in time. And so my concern is that even as awareness is growing, even as we're beginning to take action, the timeline is growing shorter and shorter. This is problematic because we don't know exactly what the consequences are going to be and exactly what that timeline is. These are very difficult problems. So when we say, for example, if you remove enough components from an ecosystem, eventually that system will collapse, or functions that we depend on or various parts of the natural world depend on will begin to fail. We know these things will happen, but exactly when they will happen is difficult for us to say because these are very complicated, complex systems. We don't have all the data, and the context is changing all the time. As we take action, or as we fail to take action, as we find new ways of exploiting systems, it's a shifting landscape. What we do know is that we're heading for a collision, and if we don't know how fast we're going, and we don't know how distant that other target is, the best course of action is just begin to apply the brakes.
And
right?
we're sort of culturally trained to be optimistic. You know, we'll figure it out. Technology will save us. We'll be all right. You know, kind of that can-do spirit. In a way, that's really harming us because we're, you know, twiddling while home is burning and species are dying.
There's a fallacy of technology. We have been incredibly successful over the last 300 years, beginning with sort of the modern revolution in Western sciences and spread to the rest of the planet, where we're actually beginning to figure out how nature works, how the universe works, how our planet works, and we've been able to take advantage of that with industry, with health. It's led to greater populations, greater prosperity. But of course, that's all rooted in science, and when science tells you we think something is going very wrong, this is the very same way of knowing that we've used to create much of the problem. And if you're fine with taking advantage of all of those things, then you want to listen to that same way of knowing when it tells you, okay, we need to put the brakes on, something's going wrong here. I also wanted to get back for a quick moment to that sense that we need nature in the background. And you know, there's a cottage industry these days in sort of post-apocalyptic thinking, movies, whatever, literature, and there's something appealing to a lot of people about, you know, what would it take to survive in a world in the future where, you know, whatever's happened. If you look at those films or you read those books, there's one almost entirely consistent thread throughout it, and that is that human society, whatever it is at that time, is living in a devastated environment. I think if you want to convey to people the picture of a failed world, even if you're saying it's a human world that failed, you automatically add a devastated environment to it, and we get it.
You are being called to stand up and speak up about what you're finding. Who would have ever imagined that there would be anyone questioning so-called intelligent people leading our country in Washington, D.C., who are actually not only dismissing science, but denying the science that they're finding. And I think the media could do a lot more in between the scientific community and the general public. You guys have to go more directly to the public, and is that something that you think enough of you are comfortable doing or can get more comfortable doing?
We're getting there. I think there's a very broad recognition in the scientific community that we have to do the communicating. I think, you know, science is built primarily on communicating with other scientists, and that's how we check ourselves. Science is a self-correcting process, and it's a fairly brutal process.
There's certain segments of our society that are attacking a group.
And we have to learn how to deal with that also. When it becomes personal, I think it's because you have no intellectual basis for your argument, and that's why you will have folks in DC and other places accusing scientists of having an agenda. I don't get paid enough to have an agenda.
Researchers and activists, not exactly the greediest bunch I know.
Exactly. So it's sort of an interesting, you know, it's irresponsible. But I think scientists, as a broad community now, we do realize we have to take more responsibility for the communication. It's not necessarily something that traditionally we're trained in or that a lot of people are comfortable in, but I've seen it really change a lot in the last 10 years. We have to learn how to translate also what we do to a general audience, not in terms only of the jargon or the special nature of our language, but also what it means to a general audience. You know, so why is it what I do that might seem fairly esoteric actually have really practical implications for our everyday lives? And we have to understand that, and then we have to learn how to communicate that.
So thank you so much for your expertise, your optimism, your enlightening us, and I just really want to urge you to continue the great work and amplify your volume. And of course, that's what this fabulous film, Call of Life, does. And we're going to go to Rhea Landig now, interviewing Stuart Pym. But before we go, I just want to say, I know we all have busy to-do lists, but think about extinction on it. And if you think about it and you put those green glasses on and think about what impact can I have in my home, in my community, in my family, in my school, in my church, in my synagogue, to really start raising awareness. You all need to be ambassadors for this. It's not just for environmentalists and scientists and environmentalists who are trying to bring this content to mainstream media. Thanks for joining us.